We are at the first question of the second easier math module for Bluebook exam number 10. And as you can see, the timer is already going, and we've got time and a half set up for this section just to give me a little bit more time to explain what we're doing as we're doing it in the interface. Now, the first question here is actually what is known as a student-produced response or a numeric entry question. And when we're engaging with the digitally delivered SAT, we want to do as much without engaging our scratch work as possible. So here I pulled up the calculator so that I can use it to work through the solving of this problem as opposed to actually doing it handwritten. So I can just follow along knowing that I'm going to have to subtract 5 from both sides first. So subtract 5 from 165. That gives me 160. And then I'm just going to have to divide that 160 by 4 to discover that the correct answer is 40, and we can put it in by typing it, or we can pull back up that little keypad and put in 40. So now we'll move on to the next question, and I'm going to just scroll this over a little bit, shoot my calculator over a little bit so that we can see what we need to see. And whenever you have a more involved and lengthier question structure, what you're going to want to do is skip to the end to figure out what we're being asked for first. So this is stating how much greater was the average number of store employees in warehouse stores than in supermarkets. So again, I still have the calculator here, and I just need to know how much greater the average was in warehouse stores. So that's going to be 365 than in supermarkets. So we'll subtract that 130 from the 365, giving us our correct answer of 235. And again, we don't need to overcomplicate anything. We will move on to the next question, understanding that by not having to write down our scratch work, we're less likely to make a mistake. So just clearing out the calculator once more, we skip to the end. We're being asked for what is the minimum number of additional hours of flight time Julissa needs to get her private pilot certification. So we know that she needs at least 100 hours of flight time to get her private pilot certification. She already has 86 hours of flight time. So that's just going to be 100 minus 86, and there's my answer of 14. Again, do it all in the interface, and you'll help yourself be a little bit more efficient and accurate. So we'll just clear out the calculator once more, and in this question, we're going to just scroll down so we can see all of our answer choices. And we see the graph of a system of linear equations is shown. Okay, what is the solution to x comma y? Well, x comma y is going to be where they intersect. And we should remember that the x-axis coordinate comes first, so we need a -4, which allows us to eliminate a and b immediately. Again, do look for opportunities to eliminate as you go to minimize making mistakes down the line. And of course, it is not at -40, so we'll cross that out, and we will select the correct answer of -4, -3 before clicking next for number 5. So then underneath here, we once again just have the student-produced response directions. So hopefully once you're familiar with how this works, you don't have to look at them again. I can just leave the calculator over here. And we've got the giant armadillo has a mass of 39 kilograms. What is the giant armadillo's mass in grams? So that's going to be 39 times the 1,000 grams per. And so again, write out the information so that you don't say something accidental like 3,900, but we'll just use the keypad, put in the 39,000, and move on to the next question. Here we've got a function where f of x is equal to 4x. So this time we just need to plug in that value of 4x for f of x. So we know that 4x is going to be equal to 8, and I'm just putting it in as a reference point. It's not going to work within the graphing calculator, but that allows me to know what I'm being asked for in the algebraic structure, and now I know that I'm just going to divide by 4, and of course 8 divided by 4 would give me my solution of 2, and sure enough, if I plugged in 2 for the value of x, 4 times 2 is 8, just kind of proving it out. Again, be careful to make sure you're solving for what is being asked for, but you should be able to make quick work of number 6, hopefully. Next, we move on to a calculator or a geometry question. And here we've got triangles ABC and DEF are congruent where A corresponds to D and B and E are right angles. The measure of angle A is 18. What is the measure of angle F? Well, if A corresponds to D, well, that means that in triangle D, and because the two triangles are said to be congruent, congruent just means the same in geometry language, basically. So we're going to set this up so that we know the sum of the degree measurements for triangle DEF when we're trying to search for angle F here is going to be D plus E plus F. And so if angle A is equal to 18, so too is angle D. So we know D is equal to 18. I know that, and I'll just scroll this up a little bit here, make it, it really doesn't make it much bigger, but I know that D is equal to 18, and I'm going to just get rid of that little, whoop, come back here, fella. Nope, definitely hit the wrong button there. So where's my little, oh, I gotta hit it here, and that'll just allow me to see what I need. And then we know that E is going to be a right angle, so that's just a 90-degree angle. So I know that F is going to be equal to just 180 minus the degree measurements of the other two angles, which are 90, and that 18, which gives me my answer of 72. Be organized, work through the problem, and hopefully you can make quick work of something like number 7. Next, we have number 8, and you can see I will get rid of the calculator just so I can see everything more clearly. Of course, you'll have the full screen. You won't have your scratch work up on the computer screen when you're taking your official or most likely your practice SAT exams yourself. But I'm going to skip to the end, figure out what we're being asked for, and we're being asked for the value of x. And we should note immediately that line M is parallel to line N. So that means that we are creating alternate interior and exterior angles. So this 33 right here is also going to be on the other side of the X for either line T or line M. So we know that X plus 33 has to add up to 180, very similarly to what we just did in the previous problem. So if I do 180 minus 33, I get my answer of 147, and we should be able to move to the next question immediately. Here, we've got a system of equations, and I probably have the first instance where we're going to engage with the scratch board, because we're being asked for what y is equal to. And anytime I do engage with the scratch work, I want to write that down for clear reference, and I'll box it off so I don't lose sight of it. And here, we're being asked for that value of y, and we've been given two equations. And it's at your discretion whether you believe that setting it up as a system of equations, meaning adding the two equations together to just isolate for y, or substitution is fastest. It's an entirely 6 of one, half dozen the other structure with this problem. My preference generally, though, is going to be the system of equations. So we've got 3x is going to be equal to 12. And then we've got our second equation of y minus 3x, and I just rearranged things a little bit so that it's easier for me to see how the different variables work when we're just looking at x's or y's, and then we've got that equal to negative 6. So then I can just add these two equations to each other. So if I just add a y, I get a y. But if we add negative 3x to 3x, the 3x's cancel out, and then we'd have 12 plus negative x. Remember, you have to distribute this addition throughout the second equation, and 12 plus negative 6 is going to be equal to 12 minus 6, or positive 6, which is our correct answer of B. Our alternative with substitution would have been to just plug in 12 for 3x. Don't solve for x individually. It is a waste of time. So we'd have negative 3 times 12 plus y is going to be equal to negative 6. So now, if we set that up, because we've got, oh, well, and I just did what I was talking about, as I was looking at this and going, wait a minute, something seems off. It's because it's not negative 3 times 12, which is the trap that you could walk into. So just illustrating, as we're working through these, those traps that do appear, I know it's really 12 just being turned into a negative. So we've got negative 12 plus y is going to be equal to negative 6. Adding 12, and we get y is equal to 6 again. And actually, that's a great illustration just of how, if you think about this too conventionally, you can walk into the trap. by doing the system of equations, we actually avoided the trap entirely. You saw your instructor actually think about walking into that trap real uncarefully there, which again just illustrates how you need to engage with the scratch work on a problem such as number 9. But we'll move on to the next question now. So here we're just looking for an expression that is equivalent to 9x squared plus 5x. I do think that it's probably easiest to put in the put this just by factoring. So I should recognize that when I factor an x out, and I'll just do this on the scratch board over here, that we pull out an x, you're going to have 9x plus 5 in the parentheses, and that's going to match choice A. And when we look at the rest of the answer choices, you could also just kind of consider multiplying them through. Obviously, 5x times 9x is going to give me 45x squared. 9x times 9x gives me 9x squared, but 9x times 5 is going to give me 45x as opposed to 5x. And then x squared times 9x is going to actually give me 9x cubed plus 5. So there's three kind of proof of concepts of how those are incorrect. And one more way that you can actually engage with this, just to kind of show you how the Desmos tool can be used, is if I put in 9x squared plus 5x here, I get that equation. And I can actually test the other, and we'll just set that as equal to 0, of course, because then that's going to set that up so that I can, well, I'll actually keep it as just 9x squared plus 5x. It's still going to be easier to probably see in this instance with this fashion. And again, it doesn't really matter that it's not perfect. We're just trying to see which one's going to be the exact same. And if I put in 5x times 9x plus 1, well, now I see that my chart has actually shifted. But if I were to put in x times 9x plus 5, oh, it's right on top of the other one. So again, you can see how using Desmos, we can still get to the right answer. And really, as you're trying to build your skill set up for the math section so that you're not seeing the easier questions down the line in the second section or the second module of the second section, it's really important to try to think about multiple approaches to solving these questions, because flexibility is the number one skill that's rewarded on the digital SAT math section. And that's going to encourage your ability to execute the next time you take a practice exam or ultimately on your official test day. So we've got choice A for any number of like 3 different ways for number 10, and we move on to number 11. So we are looking for an equation that represents this situation. So I would probably advocate for not engaging with the scratch work here unless I absolutely need to. So we know that Jay walks at a speed of 3 miles per hour and runs at a speed of 5 miles an hour. And he walks for W hours and runs for R hours for a combined total of 14 miles. Okay, so the combined total is going to be 14. Let's just eliminate C and D immediately. Then we know that the 3 miles per hour for W hours, it would be 3 times W, the number of hours, W are the hours, is going to give me my 14 miles. So like if he goes for 2 hours, it's going to be 6. So that's what we're looking at here. And we know that it's not the fractions. And sure enough, if I really wanted to, and again, just using the scratch work more so to illustrate the situation, if I wanted to model this, I could say W could be equal to, oh, I don't know, 3, and R could be equal to 1, because that's going to be 3 times 3 is 9, plus 5, that gives me my 14. And of course, 3 times 3 is going to be 9, plus 5 is going to be 1, or sorry, 5 times 1 is going to be 5. And so you could prove it with a little bit of a model, but hopefully you don't need to engage with that when you're going through easier questions on the digital SAT. So our next problem, as we reach past the halfway mark of this section pretty quickly, we're looking at what is the perimeter in inches of a rectangle with a length of 4 inches and a width of 9 inches. So if I need to, I can go to the reference and find information about a rectangle right at the top here. And we've got L and W, and we should know that the formula for perimeter of a rectangle is going to be 2 times L plus 2 times W. So let's just use the calculator here, because we could certainly just put this straight in to that calculator to avoid bringing it onto the scratch work. So we've got 2 times 4 plus 2 times 9. And there's our answer of 26, and we can just move straight on from number 12. Next, we've got number 13, and it says a line in the xy plane has a slope of 1/9. Well, don't even keep moving. We're going to eliminate anything that has negative 1/9. And passes through the point 0, 14. Well, that's going to be a positive 14, not a negative 14, so we can eliminate choice C. We would select choice D, and we should remember that y equals mx plus b is the standard form of a line in the coordinate plane, where m is the slope, so that 1/9 in front of the x is the slope, and plus b, the b is the y-intercept, and that would be our 14. So we move on to the next question. Here we've got a question asking for the value of C. We should know, but if we don't, we can come back to just how the Pythagorean theorem works, kind of illustrated by our special right triangles, as well as the actual Pythagorean theorem here. We know that the hypotenuse of C squared is going to be equal to A squared plus B squared. So once again, I am inclined to do this in the interface if I can. So I'm going to just take 4 squared plus 5 squared is going to be equal to C squared. So now I've got 41. So I know that C is going to be equal to the square root of 41. So we can do 41 and, oops, my square root has to come first. So we'll put that right there. And my square root of 41 is going to be 6.403. I'm probably not going to do this where I have to actually simplify this in any meaningful way. But I know that the square root of 41 is certainly not 4 plus 5, that's 9. And if we're looking at 5 times 4, that's the square root of 20. The square root of 20 is not the same as the square root of 41. I don't even care what it exactly is. It's just not the same. 4 plus 5, though, of course, is going to be 9, and the square root of 9 is positive or negative 3. Of course, it's geometry, so you're not going to have a negative, but we can eliminate C for that reason. And then, and only then, we get to choice D. 4 squared is 16. 16 plus 5 squared, or 25, is going to give me my square root of 41. We didn't even have to draw it. You don't want to draw generally unless it's absolutely necessary. And you could just use the Pythagorean theorem all within the calculator to work through something like number 14. Then, number 15, we're being asked for the number of cupcakes that Vivian bought. So when you've got more complex structures, again, multiple variables, that sort of thing, we're more inclined to track it algebraically on our scratch work. But we need to get down what we're being asked for first. We want the cupcakes bought. And we're going to just put that in a box so we don't lose sight of it. And we'll just call that C in parentheses. That's going to be the C variable. So party hats and cupcakes were bought for a total of $71. So I'm going to just write total equals $71. And we know each package of party hats cost $3 and each cupcake cost $1. I probably don't even need to write that down. We can keep track of it. And it says that Vivian bought 10 packages of party hats. So we know that the hat cost is going to be equal to 3 times 10, which is equal to 30. So that means that our cupcake cost, if I can spell cupcake properly, is going to be equal to just that 71 minus 30, and that's going to be 41. And we know each cupcake costs $1, so our number of cupcakes bought had to be 41, and we could just move on to the next question after using the number pad to insert it. So here with number 16, we could certainly use our Desmos tool. So we've got which equation defines function g. So let's just put into Desmos the function 7x cubed. Okay, so we got that set up just like that. You know, that guy right there. And the graph of g of x is the result of shifting the graph of y equals f of x down 2 units. If I know I just have to subtract 2, you could select D right now. But if you don't, you could just go ahead and see whether these answer choices go right on top of what we had with 7x cubed in the graphing calculator. So if we did 7 halves times x cubed, I go, it's close, but it's not quite right on top. So A would be out. Then if we did 7 But this time, whoops, got to get back down to the next little line there, 7, and this time we had x raised to the 3 halves. Well, now I can see that I've got a completely different like green line here too, and you can zoom in a little bit to see that it's different, but it's certainly not B. If it were looking to shift it down 2 places, it's not shifting down. We saw with the previous one of 7 halves times x cubed, it wasn't shifting down, it's kind of like expanding out, if anything. If we did 7x cubed plus 2, however, oh, hey, it shifted up 2, which kind of indicates what we're looking to do is going to be shifted down 2, and there's my shift of just moving it straight down 2. And of course, our correct answer is D. If you know it theoretically, you don't have to do this work, but of course, you can use the Desmos calculator if you're having any trouble. It's a great resource. So then, taking a look at this next one, we've got x plus 7 is equal to 10. And we're trying to figure out what is a solution to the system of equations. Well, if x plus 7 is equal to 10, well, then we know that 10 squared is equal to y. So y has to be equal to 100, and I don't have to do the rest of it at all. I know that y has to be equal to 100. There's no other reason. There's no reason to keep going from this point. Again, if you want to use this as practice down the line to kind of expand and work through everything, you can, but when you're in a timed exam, you just move on. So this next problem here has a scatter plot showing the relationship between 2 variables, x and y, and we've got the line of best fit. So we're trying to figure out what the closest slope is here. Well, it has to be negative, so we can't have either of the positive options, and I should see that it's basically going down 2 and over 2. Down 2, over 2, not quite, but pretty close, and it's not going to be minus 3.3. You can trust any coordinate plane or graphic data interpretation graphics is drawn to scale on the digital SAT, so don't waste time going through it in any greater detail. You can just visually interpret that line of best fit and pick the estimation that has to be the right answer of choice B. We'll move on to our next problem. And here we've got a question asking for which equation could be the second equation in the system, and we're told that this one of the answer choices is an equation in a system with 2 linear equations where the system has no solution. So we should recognize that that basically means in the coordinate plane we have parallel lines that never intersect. So if we're thinking about doing this technically, I'd just be looking for something that says y is equal to 6x plus something else. And you might recognize that that's going to be choice B immediately, because you're like, y equals 6x plus 22. Y can't be both 6x plus 18 and 6x plus 22, so there's no solutions. It's going to be a parallel line. If you can do that abstractly, just go ahead and pick B now. But if you're having trouble, first, just go ahead and put your value into Desmos. So we've got 6x plus 18. I'm going to zoom out here a little bit so I can see what we're looking at. And basically, I've got a pretty high slope, and we've got an intercept at 6x plus 18. I think if I click there, there's 0, 0, 18. So now I could put the remaining answer choices into the graphing calculator and see which one is going to be parallel. So if I did, and I don't even have to shift the numbers around. So if I did negative 6x plus y equals 18, oh, it's the exact same thing. So that has infinite solutions, not no solutions, so A would be out. If I put negative 6x plus y equals 22, well, there's my parallel line that we said B already was, so we proved it out. And if you tried the other answer choices, you discover that they aren't going to be relevant at all. We've got negative 12x plus y is equal to 36. It like intersects. And then negative 12x plus y equals 18, again, it intersects at a point, so there is a solution. So just showing how you could use the Desmos tool to its full advantage here, but hopefully you would have selected choice B for number 19 a while ago on your own practice. And then number 20, we're being asked for the x-intercept of this graph. Again, I'm going to just use Desmos, and the x-intercept is where it crosses the x-axis. So it's not just negative 84. So we know that, I mean, you can actually use the f of x notation here too, equals 7x minus 84. And there's my x-intercept, and it's 12,0. No reason to do this technically. Use the tool that's at your disposal. Of course, you could plug in 7x minus 84 is equal to 0 and solve, but why do the extra work on the digital SAT? Moving on to question 21, the penultimate question of this section. And we can see we're being asked for what is the value of g of 4 this time. So we've got a structure, and once more, it got a little bit more convoluted. So let's go ahead and engage with our scratch word just for a moment. We know that g is defined as g of x. Oh, and I should have, of course, written out g of 4 equals question mark as what we're being asked for. Don't ever want to lose sight of it. So we know g of x is equal to 19 times a to the x power. And a is a positive constant, so I'm just going to write up here, a is greater than 0. No, it can't be a negative. So g of 3 is equal to 2375. Okay, so that means g, when we plug in at 3, is equal to 2375. So that means that 2375 is going to be equal to 19 times my a to the third power. So what I need to do is come use my calculator. We'll do 2375 divide by 19 first, which gives me 125. And so now we know that 125 is equal to a to the third power. And technically, what we need to do to solve for what a is going to be cube rooting. The easiest way to cube root over here in the calculator is to just go ahead and do 125 in parentheses and raise it to the fractional power of 1/3. And you'll discover our solution is 5. So we know now that a, and I'll just put it over here, is equal to 5. So if a is equal to 5, and we're trying to do g of 4, well, g of 4, we're going to have to do 19 times 5 to the 4th. So let's go over the calculator to clear things out once again. And so I'm going to just do 5, not squared. I'm going to do 5 to the 4th. And we're going to take that 625 and we're going to multiply it by 19 to complete the function. And I'm going to just use the keypad, 11875. And that is going to be our answer for number 21. Before we move on to the last question, we'll clear everything out just in preparation of doing it. So we got everything cleared out, and we are being asked, if we skip to the end, for the value of k. So the population of Greenville increased by 7% from 2015 to 2016. If the population is k times the 2015 population, what is the value of k? Well, it increased, so it cannot be 0.07 because that would be a lesser value. So too would 0.7. But if we did 1.07, that would give us the exact conversion of 7%. 1.7 does not. But if we wanted to set this up with our full percent change formula, we should know that percent change is going to be equal to the difference in the two values divided by the original of the two values times 100. So here, let's just say theoretically, we set up an easy value for 2015 and 2016. So we'll say 2015 population is equal to, oh, I'll just go with 200. And then 2016 goes up by 7%. So that's going to be equal to 200 plus 0.7 of 200. So if we don't know how to do that, we could just do our 200 times 0.07, and there's our 14. So we know that the 2016 population is 214. So we know that 214 is equal to 200 times k. And if we divided both sides by 200, we would discover that 1.07 is equal to k, just as the proof for how to work through any percent change style problem on either math module of the digital SAT. So when we click next, you'll want to close out the calculator. Oh, and I didn't put in my answer. And that's the benefit of going to the questions, right? When I hit next, I see all of the questions. Make sure that you do answer all of them. And whenever you're ready, after checking the work, if you've gone and flagged anything for review, you could just hit next. And since this is the final module of Bluebook exam number 10, for instance, you'll have to click it. The module will be over. Everything will be saved. And once it's done, it's going to tell you to hang out with the app for a moment because it's going to upload to this mypractice.cb.org. If you can't find anything, it probably means that you didn't complete that process and you'll just have to go into Bluebook and do it one more time. Of course, there's always a little survey these days for everything we do on the internet. But hopefully this review of all of the questions from the easier second module of the math section in Bluebook exam number 10 has helped you better understand questions that you got wrong and maybe questions you got right too as you get ready to take your own official SAT sometime in the future.